In Lesson 8.2, we will be dividing monomials. You'll learn how to simplify expressions involving the quotient of monomials and simplify expressions containing negative exponents. How can you compare pH levels? To test whether a solution is a base or an acid, chemists use a pH test. This test measures the concentration C of hydrogen ions in moles per liter in the solution. And it gives the equation C equals 1/10 to the pH. The table gives examples of solutions with various pH levels. You can find the quotient of powers and use negative exponents to compare measures on the pH scale. Let's use the same process we did in the last lesson to find a pattern for the quotient of monomials. So if we start off with 3 to the 4th, we know that means 3 times itself 4 times. And 3 squared is 3 times itself 2 times. And we know that anything divided by itself is 1. So what we have left is 3 times 3, or 3 squared. So it appears power times power, we add exponents. It looks like power divided by power, it seems to be that we are subtracting the exponents. Let's look at another one. I'm getting a little carried away here. I've got 2 to the 6, so I need 6 2's. And over 2 to the 3rd, that's not so bad. So again, I can cancel. And what I have left is 2 to the 3rd. So again, it appears that I did power divided by power. We subtracted the exponents. That's a minus sign. Power divided by power, we subtract exponents. To divide two powers that have the same base, that's very important, have to have the same base, subtract the exponents. For all integers m and n, and any non-zero number a to the m over a to the n equals a to the m minus n. Or, for example, with real numbers, b to the 15th over b to the 7th, we'd have 15 minus 7 for our exponent, or b to the 8th. If we want to simplify x to the 7th, y to the 12th over x to the 6th, y to the 3rd, first they tell us to assume that x and y are not equal to 0 because division by 0 is undefined, and that makes things uncomfortable, so we just assume that doesn't happen. We're going to use our quotient rule that we just learned. Power divided by power, subtract exponents. To make it really clear, they put the x's and y's together. They were kind of already lined up. And using the quotient of powers rule, we subtract 7 minus 6 and 12 minus 3. And 7 minus 6, of course, is 1. 12 minus 3 is 9. Now, normally, we would go ahead and write that as x to the 1 means I have one factor of x. So we just write that as x, y to the 9th. I'm not going to make a big deal. I would accept either answer, but this is what you're going to see in the back of the book. Okay, once again, hopefully the patterns are coming. We're going to look at what happens with a power of a quotient. So fraction bar means divide. If it looks like a fraction, it's a quotient. Let's write that out. Cubed means we're multiplying that times itself 3 times. So that'd be the same as 2 cubed times x squared cubed over 3 cubed, whichever way you want to do it. We're going to get 2 times 2 times 2 is 8. X squared cubed, power over power, you multiply exponents, that's x to the 6, or you could do 2 plus 2 plus 2, whatever. And 3 cubed is 27 in my little fake example. So to find the power quotient, we're going to find the power of the numerator and the power of the denominator. For any integer m and any real numbers a and b, where b cannot equal 0, a over b is the same to the m is the same as a to the m over b to the m. Or if they had just a simple one there, c over d to the 5th power, it's the same as c to the 5th over d to the 5th. So here's a problem they might ask you to do. Simplify 4c cubed d squared to the third power over 5 e to the fourth f to the seventh. Okay, so we need to take everything to the third power. So they rewrote it with the numerator to the third power and the denominator to the third power. And here's our friend, the power of a product rule. So we did each individual piece to the third power. 4 to the third is 64. Power of a power, we multiply exponents, so 3 times 3 is 9, 2 times 3 is 6, 5 to the third is 125, 4 times 3 is 12, 7 times 3 is 21. And there she is.